Hello everybody, myself Oniket Jana. Today I am here to solve the doubt clearing session of NPTEL stereochemistry course, and today we will discuss about the problem assignment of the week 0 assignment. So let's start. Let me first share my screen. Hope my screen is visible to you everybody. So let's start the assignment section. Okay, so our first question of today is number of the Gauss-Butane interaction in the chair form of the cyclohexane. So as we know, the chair form of the cyclohexane is the most stable form of the cyclohexane. It is a Packard ring, and here no angle strain is there, but there are 6 Gauss-Butane interactions are there. Okay, so we have to know that what is Gauss-Butane interaction. The Gauss-Butane interaction is the occurs in the butane when two methyl groups have dihedral angle of 60 degree and 300 degree, and arises because of the methyl groups are still quite closer to each other. So here the methyl groups are not present, but in the chair form of the cyclohexane, the Gauss-Butane interaction occurs due to the neighboring methylene groups, and each Gauss-Butane interaction is about 0.9 kcal per mole of energy. So it is so there are 6 Gauss-Butane interaction in the chair form of cyclohexane. The next question is the which of the following is the cyclohexane in order of the increasing potential energy. So there are various options. So option D is correct, that the chair form is the most stable. Then uh, let me take the pointer. Yeah. As you can see that this is the chair form. Chair form is the most stable one, and then it is the twist boat form. Okay, then it is the boat form, and then it is the half chair form. Okay, so it is the conversion energy profile diagram inversion of two form of the cyclohexane. That is, this is the one form of cyclohexane, and this is another form of the cyclohexane. It can take place via the various intermediate states. It can go through via the two pathway. One is the achiral sigma pathway. The above one, as you can see, the intermediate transition states are the achiral one, and the below one is the chiral C2 pathway. As you can see that the intermediate forms have the C2 axis. Now here is the question is to identify the conformation which can be termed as the P-Gauge. So we can term in Newman projection, we can term a configuration as gauge when the two neighboring group, okay, on the adjacent carbon are at the, and the dihedral angle between the two groups at the 60 degree or 300 degree. So here according to that definition, the and option D is the correct, that is 1 and the 2 can be termed as the P gauge. So here four statements are there. We have to find out the incorrect statement with respect to the asymmetric synthesis. So all other statements are the correct, but the only incorrect statement is the point C, that diastereomeric excess depends on the difference in the free energies of the two possible diastereomers. Okay, here is the number of the stereoisomers possible for the compound CH3, CHOH, CHOH, and the C2H5 is. So it is this compound is not symmetrical and cannot be divided into two equal halves. So when the molecule cannot be divided in two equal halves, so the formula for the number of the stereoisomers is 2 to the power n, where n is the number of the asymmetric center in the molecule. So here, as we can see, there are two number of the asymmetric center in the molecule. So the total number is 2 to the power 2, equals to 4. So there are overall 4 possible stereoisomers are possible for with the empirical formula. So here, which of the following molecule has have highest number of the plane of the symmetry? So plane of the symmetry is a chiral plane, which a chiral plane is the plane which divides the molecule in two equal halves. So in the four compounds, compound 4 has the highest number of the plane of the symmetry, that is 3 plane, one containing the molecular plane and another two is perpendicular to the molecular plane. Okay, so total 3 number of plane of the symmetry. So it has compound 4 has the maximum number of the plane of the symmetry. So here, which of the following statement is correct regarding the following chiral reducing agent? Uh, Here, various kind of chirality is possible, but this kind of compound have the chiral axis. So answer option C is the correct one. Okay, here the similar problem we solved earlier, that how many stereoisomers are possible with the given formula. Here, as we can see that there are 7 total asymmetric centers are there. So 2 to the power 7 equals to 128 number of the stereoisomers are possible with this molecule. So which of the following is are the mesocompounds? So here mesocompounds is the compounds which where the one optical rotation of the one half of the molecule compensate the optical rotation of the another half of the compound. So according to this, compound A and compound B has the sigma plane. So A and B both are the mesocompounds in this case. As in compound C, there is no such kind of symmetry like inversion center or plane of the symmetry. So the compound C is not a mesocompound. And 10, consider the following statement: E or Z diastereomers are reflection variant, that is E becomes Z and Z becomes E after mirror reflection. Identify the correct statement from the following. If the right option is option C, may be true for system where the sp2 stereogenic carbon are bonded to the enantiotropic subunits substituents. Okay, so here we end with the assignment section. Hope your queries are clear. So let's meet in next session. Best of luck.